Today we're working on a Department 56 piece, Dr. Lunatic's lab. I'm trying to lift it. It's got a monster in the window. And there we go. Dr. Lunatic's laboratory. Say the whole name. Anyhow, it doesn't work. It's actually mine. I don't get to work on mine very often. And I'll show you. It's supposed to light up. Plug it in. Nothing's happening. This runs at 3 volts DC. This is a 3 volt DC power supply. And a lot of the times when I find stuff like this, it's due to the fact that power supply is bad. So just to show you. Free flow voltage is 4.74 volts because there's no load on it. So it's not the power supply. So the blue lights inside here don't work and the orange rotating lights up here aren't working. Now I have in the past, years ago, probably like 3 or 4, I was going to work on this and I didn't get around to it. All I did was break the glue that held the monster in to see if there was access. But that's as far as I ever got. Down inside here in this back section, or pretty much where it says the original Snow Village, is the circuitry. All this did was drop the monster out, and that's it. It really didn't do anything else. More of a hindrance now. So, need to figure out how to get into the base of this porcelain. Because ceramic. This is a ceramic house. It has a plastic top right here. This is plastic. The windows are plastic. What is unique is the railing. They're metal. So are the wrapped wires. They're metal. You don't see too much metal on these houses, so it's kind of interesting to see that they've gone to a metal versus resin setup. So, since I never got very far in this, and other than taking out the monster many years ago, and then it's just been sitting on my shelf collecting dust, that's why she's just all dusty. Trying to figure out how to get into here. So, this has, I can push it in, pull it out, so there is play through the bung, but that doesn't access inside here. So I'm trying to look at it closely. What I'm going to do is, so I'm not going to glue this guy in yet, just in case I need to remove him. I'm just going to tape it in, just so it doesn't get in my way. So I got some black duct tape. Now, once I get this working, I will, of course, hot glue it back together normally. This is just so I can maneuver this thing around and not have the monster fall out. Looking at it as close as I can, it looks like the only access to get into here is going to be from the top, possibly the side. This piece that protrudes out, this landing or patio, has glued here and here, which means it's probably also glued across the bottom underneath this nice paint job. So before I decide to try and remove this section, which potentially will break, I'm going to take the plastic top off and see if I can go down through and get to the circuitry and find out why, when I plug her in, it doesn't do anything. Now normally I would try and pop this off with a spudger, and the only problem is I have no idea where I put them. My workbench is a disaster. I have no clue where it ended up. So I'm going to use my gear / pulley puller, because it is tapered, and see if I can catch some of this edge and get this plastic to maybe separate Worst case is I will grab a heat gun and try and heat this up if I can't get any grip. I got a little bit of purchase right there, and it is starting to break the glue. I'm going to change over to a small flathead screwdriver. You can heat this. I normally do, but I've been finding recently on some of these pieces, the glue they use doesn't always separate with heat. So I try and do it without heat first. If I see any stress forming, fractures on the paint, I'll then heat it. But you got to be careful when you heat things because you don't want to destroy the paint. Wow, that is a nest of wires. Alright, so you can see all that copper wire, and some of it's corroded. I wonder if they're shorted out. And you got some green right here, and right up in there, and back here. The green corrosion, this is varnish or coated wire, and if they rub too much or scrape, they'll eat their way through, which in turn cause it to become a short. And I'm wondering if that's why the unit doesn't work. So I'm going to carefully move it away. Yeah, flexing these metal wires. You can see inside. Down inside is pretty basic. We got two itty bitty circuit boards right in there. I'm going to see if I can bring those to the surface. Let's push this in. Circuit boards are getting caught on this metal bar right here. This bar goes through the housing, the porcelain or ceramic, and it's catching. So I got to be careful that if you take this one apart, that you do not pull too hard in case it's caught. That one, just popped it off, and let's get some more slack. And here we go. Here is the two itty bitty little circuit boards. We have on the one that has the power, we have a couple of resistors, 5 on the board, 3 transistors, and a capacitor, which appears to go across the incoming power, possibly. The back has a blob chip. The secondary circuit board, which is branched off the primary, has a couple of transistors, resistors, and a capacitor, and then they're hooked up to these wires right here. These 2 copper wires that go up inside. These 2 copper wires are actually separated in the glue off to the side. Then these bundles of wires, they're all twisted together, which we have 5 bundles. We have whites, black, and it looks like 2 blacks. Oh. So we have 3 whites that come off the main circuit board, and then actually we have another one over here too. So then 3 blacks that come off of these resistors over here, and that's supposed to light up this dome. And then going down inside off the secondary circuit board, we have black and white wires, which are supposed to light up the front of this in a bluish color, well, blue, to permit you to see the monster inside. But I am really wondering if my problem with this thing failing is that the corrosion on these wires is eating through the lacquer coating. That's the word I was looking for earlier. and it's caused the boards to basically short out. Let's see if I can untwist some of this, because the bundles can be touching each other in that bundle, but you don't want them touching the other bundles to create a short, especially the blacks and the whites. And I'm sure the blacks are negative and the whites are positive. So I'm just going to carefully untwist these best as I can. I'm going to plug it back in and see if I got something to work. If I did, then I know that I have a short in these bundles. I don't know why they didn't just use regular wire. Probably because of cost. These lacquered wires, they just twist them together, then melt the ends where they do the soldering, and technically the lacquer will stay without any motion, rubbing, wear. It should technically last forever. But if corrosion gets in there, that can cause failure. And I still have nothing. So I'm using a magnifier set to check the circuit board and see if I see any discolorations, burns, or damage. I really think my problem is right here. Because this right here is not only corroded, it looks burnt. These are still copper. This one's black. Now that I have magnifiers on, I do have green corrosion up here, which comes off of one of the white bundles, and I have some corrosion down here. But these right here are actually burnt black. So these got hot. Let's see if I can get a little bit more separation on them. If I had to remove all of these and replace them, that would be a very, very, and I do mean very, painstaking job. Alright, I got more separation. The bundles are only touching themselves until I get to the hot glue joint. And still nothing. .74 volts at the power inputs. Now let's check at the outputs to this top piece. So I'm going to test a ground cluster to one wire. I have 0.6 volts to the next wire, 0.6 volts, and the last wire, 0.6 volts. Just feeling if I feel any heat coming off any of the components. Also notice the resistors on the clusters are all different. They're all different values. So the clusters do different things up inside this dome. Now what I can do to isolate this from the lights on the front is I can desolder this primary connection here where all the wires meet with the resistors on this little circuit board. And then if this is shorted out, these should light up. So let's do that. Let's turn on the soldering iron. And while it's warming up, I'm going to move some wires out of the way so they don't get damaged. It could have some bad transistors. I could have a bad resistor, or the blob chip is fried. The blob chip is right here on the bottom. It's really small. It's probably about the diameter of a pencil eraser. When you desolder, it's easier if you put some fresh solder on top to allow heat transfer. And now I'm going to try and pull this resistor pack off, which will disconnect like that. In the process, it also removed the wire from the other board, so I'm going to put that back on real quick, because the other board is what powers the front lights. Solder. So, alright, so this resistor pack, which connects this dome, is now separated. So the only thing hooked up is the 3 wires that go in here, but there's no return path. I've severed it. And then the wires that go to the secondary board, which still do have 2 wires that go up here, these 2 separate wires right here, which I'm going to hope are not shorted. And then the rest of the wires go down to the front. So let's see what happens. Still don't have any light. Let's see if I got any difference in voltage now. Let's see. Hopefully you guys can see it too. So all the white wires are positive and the black wire is negative. So I'm just going to try and see if I can check this power over here. 1.8 volts. So I have 1.8 volts still going to this dome. And let's see if I can find the power going down into the front. I'm going to unplug it so I don't arc anything while I get this smaller board out. And clean this board because the contact has glue on it. So I won't be able to get my meter in there. There we go. And this little board also has a blob chip on the back of it. So we got dual chips. Let's test her out. I'm getting 4.76 volts into the board. I'm getting voltage to the lights, but they're not coming on. So the voltage at the lights is 4.76, but none of these lights in here are turning on. So I'm wondering if I lost all the LEDs. Like a voltage surge came through and they all shorted out. The LEDs are attached to the bottom of the table. So I didn't want to glue it back in, because now I'm going to pull the table back out and take a closer look at it. So, there is one light underneath and two lights attached to the bottom of the table with fiber optic rails on both sides. That's kind of nice. It's kind of neat looking. Be even neater looking if it worked. So, I'm going to keep probing around on the board, checking the power, and trying to find out why nothing works. This may have fried the blob chips and it doesn't function because the blob chips aren't connecting to the transistors, meaning that it's not going to send the signal to the boards. That's the biggest issue with blob chips. Let's see. So going to this little LED down here, which there's one right here where my finger is, there's no volts going to it, but I have 4 volts going to these two. Because when I was testing earlier and I was getting that 4.76, that was the wires for these two. This one is soldered in a different location, so most likely it's a different voltage, or it might pulsate because I've never seen this thing work in person, as I got it as a defective unit to play around with. And that's what I'm doing now. I am kind of curious what's inside this dome to see if I can send power, since I have it disconnected from the board via desoldering the negatives. I can send power into this via my power supply and make this light up. Get that out of my way. But I'd like to know what these two signal wires are for, because most likely these two separate wires are just signals to tell it to do something. So let's see if I can scrape off some of this glue that's right here and see if I can separate the top and the bottom of this dome without stabbing myself too much. a screwdriver inside around the edges to try and get it to separate. I'm getting all the pieces that fall out that the glue is. So let's take a look at what's inside here. Oh wow. Not what I expected. I'll be able to show you all here in a second. 3. There we go. Those 2 separate wires are the light that goes up here. But that is a cluster of LEDs. That is a monster cluster of LEDs. That is a lot of work to make that. We got yellows, oranges, and reds. And let me just make sure that and these 2 wires that go up inside here are these 2 wires right here. So this light here works in conjunction with these up front because it's on the board that runs these. That, though, that is a lot of little LEDs. And because they're the varnished or lacquered wires, if any of these are shorted out, like this orange one that's back here, it's going to be really hard to show you. The wire going into it is black. And then this red one has a black wire. And this red one's got black wires in it. Probably about 8 of these have burnt wires, burnt or corroded, because they're not shiny copper. They're black and then they fade back into the shiny copper. So I have a funny feeling that some damage was done. Could have plugged the wrong power supply into it and fried everything. Not sure. So these are into my power supply, which is a DC power supply. Right now I have it set for 2 volts, which is less than what this unit runs at. Because I don't want to I just want to see if I can get something to illuminate. So I'm going to hook the cluster of LEDs to the black. Then I'm going to touch the positive to the solder joints on the board and see if I detect a short. No. Alright, so I'm going to pump up the juice because they're actually working. This is giving me the idea that the blob chips are probably bad. This thing probably got overpowered, wrong power supply by its previous owner. So I'm going to try and do this where you might be able to see on camera. What I'm going to do is I'm going to turn off the light right here. And I'm going to try and prop this up. This is my process of elimination to try and narrow down what's going on. I might have to build a new circuit to replace what's in here, because these right now are going functional for about $300. Non-functional, I can find them as cheap as $1.25, which is way too much money to still spend. So this is touching pad 1, touching pad 2, and touching pad 3. 2, 1, 3. So, because when I saw this in a video on YouTube, these were rotating. So those 3 pads was on, and it would just go in a circle. On, off, on, off, on, off. So it would give it the indication that it was flickering or rotating around. So I do know, at least, that these all work and they're not shorted. If they were shorted out, my meter, or my machine, and I'll show you, will do this. That tells me there's a short and it stops the voltage so it doesn't damage the machine. So I could have bad transistors, or I could have a bad blob chip that's not telling the transistors to turn on. The reason they're flickering is I'm going between the pads to try and touch 2 sets at the same time. Each pad is pulling right around 1/4 amp. So we know that this actually does work, and I most likely have bad blob chips. Now, I'm going to do the same thing to see if I can get this to illuminate, but I'm not going to desolder it, because I have a funny feeling that the board's damaged already and there's not much I can do about it. But I am going to turn it down because the resistors are soldered to the board, so I'm going to drop this thing down to 2 volts again. And that's the negative. And I'm getting 0 continuity when I touch the positive. It's showing it's an open circuit. So the lights down there don't work. Just to make sure I'm not seeing coating, I'm going to scrape the solder joints just to make sure there's no glue on them, and we're going to try it again. I'm getting no illumination. Nothing. Alright, I'm going to bump it up just to 3 volts, and I'm just going to tap it and see if anything happens. Maybe the lights require a higher voltage. I'm getting no current and nothing's flickering. Just gonna try and get the monster back in real quick so I can get the board farther out, and I'm going to check more of the circuitry. I don't do a lot of Department 56 for a couple of reasons. One, they're more expensive. 2, they're not too many that are animated. And 3, they don't break as often. It's probably why they're more expensive. So it's kind of tangled up in his wires, but I just want to get it in enough that I can tape it and get this board out farther. And light's coming back. Yeah, the lights are gone. Just to make sure it's not going backwards through the board and going through a short or killing its circuit going through the other components, although it shows I have no current draw. I'm going to remove the wires, just like I did here, one set, and clip it again one more time. If that's the case, then I know at that point both circuit boards are bad. I already know this one's not working correctly. and I'll have to find a way to make this functional in some fashion, since they don't sell spare parts like circuit boards. There we go. Alright, I am putting 2.4 volts and there are no lights coming on inside of the unit. You should be able to see a blue light in here. Nothing. So, what I'm thinking happened, since I do not know, like I said, I bought it non-functional many years ago, is I believe they overpowered this. This adapter, which is again the little 3-volt one from Department 56, this one actually went to the haunted rail engine and coal car, because I can't find the one that came with this, although they're all basically the same. When they say 3-volt, the difference is the plug end in some cases. This is also compatible with a 4.5 volt from Lemax, 12-volt power supplies, and a lot of things out there like Mr. Christmas and Department 56. They have 12-volt AC adapters that will plug into this. And I have a funny feeling that at some point in its history, a much higher power, 12-volt, or maybe even a 6-volt power supply was plugged into this, which would explain the burnt wires, that it overpowered it. Luckily, it probably didn't do it quick enough to damage any of the lights, since of course these are lit up, but just these. And because these have their own resistors, I'm going to try and lift this closer to the camera, or I might tip it up and zoom in. We'll see what works. Yeah, I'll just zoom in, make life easier for me. If I don't drop it. If I drop it, then of course it's broke more permanently. So, if it focuses, you can see the discolorations, and you can see these are black. They're not black as in completely burnt, but you can see that a couple of the strands are almost completely black, and then we have the corrosion right in here, which is probably also from overheating, and it's causing the lacquer to get hot and separate. So when I was saying about the resistor pack, here's the cluster of resistors that are all connected to a couple of these bundles that go up into this piece here. And when we flip this bad boy over, down in here, the ends where they go into the heat shrink, so it protects the solder and where the lacquer was burned off from the soldering, a handful of these are burnt black as well, which again could be corrosion, or that could be the heat of the soldering iron or soldering machine. I don't know how they did it when they put all these LEDs in, and sometimes they got hotter than others. So that's a possibility up here. Down here and up here going through the glue bung they made, I'm going to have to say it's an overpower. So looking at the circuit board, we're going to try and bring in the frame. There we go. We got 3 resistors, capacitor, and 3 transistors. Sorry, 4 resistors. My finger was covering one. They're not discolored. I'm not saying they're not bad. But normally when a resistor goes, it discolors. It gets a black spot in the middle where it's tapered. Most likely, the transistors, resistors, and capacitors are still perfectly fine, which I can test with the multimeter that's off camera now, since I'm zoomed in. But what happens when you overpower these, if it doesn't destroy a discrete component, such as one of those, destroys that blob chip right there. And on the other circuit board, this blob chip right here, you might be able to see in the camera, that got hot. I don't know if you can see the bubble in the middle. I kind of rotate it back and forth. You can see how the light's reflecting off the center, but not the edges. The center is glossy and it almost looks cracked. When I use a magnifier, such as the types like that, and look at it, it's fractured. The glossy is gloss, the outer edges is matte, and then the white around it kind of looks like you got smacked with a hammer and it cracked. That's what's leading me to think that this was overpowered before I bought it. Somebody used the wrong AC adapter. And if you fry the blob chips, they are not repairable. If you smoke a component, they're repairable. These are standard transistors. Most transistors that they use in the animated houses, whether it's Department 56, Limax, Mr. Christmas, so on and so forth, they use basically just 3 different ones. And they're easily found on eBay or Amazon in packs of 5, 10, 20, etc. And resistors, easier to find resistors is to find pennies on the ground at a gas station. So the discrete components are simple, but I have a funny feeling this is not going to be repairable to OEM due to the fact that the blob chip, especially this guy here, has taken a beating. This one, even looking at it with a magnifier, it doesn't look bad. There's no indications of cracks in the resin. There's no indications of any melting that I could see when I was using my magnifying specs. The only thing I can determine is when the power spike came in, because it branches off of here and went to this one was more sensitive, probably because there's less load on it, because it only controls the 3 lights here and the 1 light up on the top of this dome, and it couldn't handle the surge. So at this point, this piece is done. I'm going to zoom back out, see if I can do it without zooming in first, because I always do that. Oh, look at it the first time. So at this point, this piece is, well, it is what it is. It's a display piece. There's no function. But I will probably end up building a circuit that will rotate through these lights that imitate the OEM video I found online. And I'm going to try and watch a thing on this to see if the lights are solid or if they pulsate. And if that's the case, I can build a circuit to do the same thing. I have built circuits for my display for the platforms I've used where they pulsate or flash. I have built rotating circuits. Matter of fact, I'm going to grab one off camera. This is a part of the swinging ghoulies. The circuit board that goes in here exploded, and the chip literally just wiped off the board. It's the most interesting thing I've ever seen. So I resoldered all the wires, and I have a rotating chip that flashes the lights alternately, so it imitates the OEM setup. I haven't finished this piece because this is a pain to work on. If you have the swinging ghoulies and it breaks, whether it burns out the lights or it breaks the gear, I'm not going to lie, it's one of the harder pieces from Department 56. Matter of fact, this is the circuit board. And I'm sure that this blob chip here is imitating this blob chip here. This blob chip, you can see the blob is completely gone, and we just have a pad underneath. This is what was in that swinging ghoulies cap. It exploded. Never seen that before. But this one down here has the same white remnants around the edges as this one does. I have a funny feeling that they both were overpowered because they both can be plugged into the wrong AC adapters. So at the moment, in this 45-minute video, it's not repairable to OEM. I'm going to go online, watch some of the YouTube videos and the Department 56 videos when they were marketing this brand new 16 years ago, and find out what circuits I can build to bring this back. And then if I can find circuits that will get this close, or maybe I want to change it up a hair, I will then film part 2. Also, We'll replace all the lights in here since none of those three are working with direct power, starting at 2 going up to 3 volts. If they're blue, like I saw in one video, or purple, 3 volts should turn them on. If they're a lighter color, like the red, orange, and yellow in here, they'll turn on at a lower voltage, such as 2 volts. That's why when I had it down low, they still turned on. They have a much lower forward voltage, but the darker or the brighter, the blues, the purples, the UVs, and the whites have a much higher forward voltage, and they're still not turning on whether I drop it to 1.5 or work my way up to 3 volts, which is the max the power supply puts out under a load. They don't turn on. So this is more how to disassemble this to get into it versus how to repair it at this point. So that's how you take it apart. You can pop out the monster from the bottom, break the glue, pry them out, and replace one of the 3 lights that are in here, or all 3 if necessary. If you don't have any dome lights or the whole thing's bad, you might have popped your blob chips. But if you see this thing rotating and there's a couple of dark spots, maybe a couple of these are burned out, this is how you get to them. If you can't find this specific style LED, which is a very unique style I haven't seen in a very long time, you can use standard 3mm LEDs to replace them. The forward voltages are still basically the same. It'll still run on the 3 volt power supply without any issues. You can heat this if you want, so you're less likely to pull up pieces of the porcelain or ceramic. But some glues just become super sticky when they get hot. That's why I always try and crack them first, and that's why I use the term crack, because it sounds like you're breaking everything. Secondly, when you do put this back together, there is a little tab that sticks out right here that lines up in this hole right here to keep this centered. Hopefully you can figure that out, because the worst case is you're just going to wrap these wires around the top and it's not going to fit right. So, but you do have to pry out this dome to get to the 2 circuit boards. And then be careful that you do not chafe these wires, since they are lacquer coated, and that if you chafe them, you'll change the, you could potentially short them out if the white and the black touch each other. So just be careful. You can rerun this with stuff like this where it's insulated, but that's a lot of wire, and this is going to take up a lot more space because this wire is much thicker because of the insulation. The wire on the inside is the same size. It's the wire insulation that causes it to become more of a hassle. You can even use thinner wire, such as telephone, which is solid core, just like this. This is a telephone wire. It's a single strand of it. It's rigid. It keeps its shape. But you have the same problem. This insulation is increasing its diameter by almost 2-fold compared to these wires here. So, but this is Dr. Lunatic's lab from Department 56, laboratory. Sorry, they don't abbreviate it. To get inside, to access the circuitry, you need to pop the dome off. You don't have to worry about the monster. If you need to change or check the lights on the monster, remove all the glue, pop the bottom, and then walk it out. It doesn't just drop straight out. You have to kind of tip it sideways so that the table and his arm that's hanging off it, you don't snap it off on the bottom of the housing itself. And then be careful with it, because it is mostly a ceramic piece. If you drop it, you will crack it, and you can see the white ceramic on the inside. And so, other than that, that completes this episode of Captain Chaos's Laboratory. It wasn't a repair, it was more just of a teardown and diagnosis. So, in a future video, once I get through the 50 or 60 that I have piled up at the moment of ones that were shipped to me, I'll work on this again. But stay tuned for more as I can get parts to repair them. I will be putting them up. Right now I am having a problem finding certain motors and certain gears for certain pieces. I literally have about 13 or 14 of them disassembled in different stages that are partially filmed as I'm trying to locate the pieces to repair them all the way. Once they're repaired and I've sourced the parts, we'll put up a video and you can watch on what they are. So until the next one, thanks for watching.